Hello and hi. Today we are going to discuss topic 9.6, problem on maxima and minima. If you look at your success workbook, it will be on page 206. If you look at your topical past year, which is the orange book, will be on page 101. So we go straight to the concept. Suppose that we have the function of area, such that area is a function of x. Hence, if we lower the graph, we will have a against x, and probably the graph looks like something like this. And again, if you want to find the maximum or minimum area, we have to let dA over dx equals to 0. And say we have a function of volume, such that volume is a function of maybe t. So if we draw the graph, it will be v against t. And again, if you have, say, the graph looks like this, at maximum volume, or maybe minimum volume, maximum or maybe minimum volume, the differentiation, the gradient function dv over dt, why is it over dt? Because it's a function of t, will equals to 0. And it can be applied to finding maximum minimum area, finding maximum minimum volume, finding maximum or minimum length or height or mass, depends on the question. Let us go straight to example question. Turn to self-access 9.6, question number 1. Find the minimum value of L equals to 3x squared plus y squared if x and y are related by the equation 2x plus y equals to 1. We let L equals to 3x squared plus y squared as equation number 1. And if we want to find the minimum value of L, we need to find dL over dx equals to 0. The thing is, we have y here. We cannot have y because we want to differentiate with respect to x. So what we need to do is we need to substitute y with terms in x. What are the information that we have? We have this information here. We have 2x plus y equals to 1, which indicates that y equals to 1 minus 2x. Let's let this equation as equation number 2, so that we can insert 2 into 1. So we have L equals to 3x squared plus with y, which is just 1 minus 2x to the power of 2, and we expand and simplify. So we should get to 3x squared plus 1 squared minus 4x plus 4x squared. So simplify the like terms. 3x, 4x squared should get 7x squared minus 4x plus 1. And again, our aim is to find minimum value of L. At minimum, to find minimum value of L, we have to let dL over dx equals to 0. As we can see, L is a function of x. So we differentiate the function L. So should get 14x minus 4 equals to 0. Hence, x equals to 4 over 14, which is just equals to 2 over 7. Now we have the minimum value of x. Hence, to find the minimum value of L, we insert the value of x into the function of L. So the function of L here is 7x squared minus 4x plus 1, so which is just equals to 7 times 2 over 7 to the power of 2 minus 4 times 2 over 7 plus 1. So use your calculator, you will get the minimum value of L is just 3 over 7. Question 6. Read the question. A piece of wire is used to construct a cuboid such that the length of its base is 3 times the length of its width. If we draw the cuboid, it is said that the length of its base is 3 times the length of its width. So if the width is x, the length of the base should be 3x. And the height will be denoted by the letter h. The condition is that the total surface area of the cuboid is 5096. Means that the total of all the surface is 5096. Find the minimum length of wire required. So the question wants us to find minimum L. To find minimum L, we need to use dl over dx equals to 0. So first we need to find the function of L. L is just the length of wire required. From the picture, total length L is just equals to, let's see, 3x times 1, 2, 3, 4. 4 times 3x plus with h, 1, 2, 3, 4h plus with x, 1, 2, 3, 4x, which is just equals to 12x plus 4h plus with 4x. So it's equals to 12x plus 4x is 16x plus 4h. And if we want to find the minimum value of L, we need to find dl over dx equals to 0. The problem is we have h here, so we need to change h in terms of L. So in terms of x. So what other information that we have? It is given that the condition is that the total surface area of the cuboid is 5096. Total surface area is equals to 5096. If you look at the picture, the area should be 3x times h. We have in front here and back here. So 3xh times by front and back means that times by 2 plus with from the sides here, this side is x h, and we have right and left, so 2 plus with top and bottom. So we have the bottom, we have 3, area should be 3x times with x. We have 2 because it's top and bottom. The total surface area is equal to 5096. Now we simplify the equation. So 3 times 2 is 6xh plus with 2xh plus with 6x squared is equals to 5096. And we want to make h as subject matter, so we move 6x squared to the right hand side, so 6, and this is like terms, we can add together, will produce 6 plus 2 will produce 8xh equals to 5096 minus 6x squared. And everything can be divided with 2, or you don't have to divide by 2, but you can divide by 2. Let me try to simplify. Maybe divided by 2, everything divided by 2, we will get 4xh equals to 2548 minus 3x squared. And we want h as subject matter, hence we have 2548 minus 3x squared over 4x. Now we have h. Take the value of h, insert in this equation here. So it will equals to 16x plus with 4 times with 2548 minus 3x squared over 4x. And we simplify. Becomes 16x plus with 2548 over 3x squared divided by x. And we can separate this part here. Becomes 16x plus 2548 over x minus with 3x squared over x. And simplify even further. L should be 16x plus with 2548 x to the power of -1 minus with x, and x can be cancelled. Left us, we cancel 1x, so 1x cancel, leaves us with just 3x. Now we have the function of L. Okay, let me resize this and put it here. Our aim is to find minimum length required. So since we have the function L equals to 16x plus with 2548 x to the power of -1 minus with 3x, minimum to find minimum L, we need to differentiate the function L in terms of, in this case, x, that it equals to 0. So we differentiate this function here. It becomes 16 minus 2548 x to the power of negative 1 minus 1 minus with 3 equals to 0. So 16 minus 2548 x to the power of negative 2 minus 3 equals to 0. Like terms, 16 minus 3 is 13. And then I move this term this term here to the right hand side. It will become 2548 x to the power of negative 2. And if I rewrite back, it's just 13 equals to 2548 over x squared. So make this as the subject matter. So x squared equals to 2548 divided by 13. I just swap the position. Hence, x is just equals to the square root of 2548 divided by 13. You should get the value of x by calculator. You should get the value of minimum x is 14. So this is what we get is minimum x, not minimum L. The question wants you to find minimum length. So what you do, you insert the minimum x into the L function here. Want to find minimum L is just equals to 16 times with x 14 plus with 2548 times with x 14 to the power of negative 1 minus 3 times with 14. Press your calculator. Your final answer is that right? I don't think it's right. It's right. Press your calculator. You should get 364 centimeter. It's a bit complicated, but it's manageable. So you can always, rewind and go through the questions slowly and understand. Try to understand. If you have any question, you may ask me when we're back in school. Maybe let's do one more example. Page 101, example 14. Let's read the question. A sector of a circle of radius r has an angle of theta radian. As we know, sector looks like this. An angle of theta with radians RCM. And this is also RCM. And given that the perimeter of the sector is 30 centimeter, and if you look at circular measure chapter, the length of arc is just equals to r times with theta. And given that the perimeter of the sector is 30 cm, we have perimeter is just equals to 30 centimeter, which means that if you look at the picture, r plus r theta is equals to 30 centimeter. Simplify, 2r plus r theta is equals to 30 centimeter. Question number 1. Show that the area A of the sector is given by A equals to 15r minus r squared. And we need to show that A is equals to 15r minus r squared. So we know by formula, area of a sector is given by formula A equals to 1 over 2 r squared theta. But the thing is, we don't have no theta here. Everything is in terms of A. We need to prove this. So which means that we need to change theta in terms of R. So from the information that we have given before, we can actually make theta as the subject matter. So we have r theta is just equals to 30 minus with 2r. Therefore, theta is equals to 30 minus 2r divided by r. Use this value, insert into this equation. So we should get 1 over 2 r squared. Theta is 30 minus 2r over r, and simplify. So if you open the bracket, it will be, let's see, so 1 over 2r times with 30 minus 2r equals to 1 over 2r times 30. This times this one, this time this one, minus with 1 over 2r times 2r. What I did here is I just opened the bracket. So 30 divided by 2 is 15r. And here 2 divided by 2 should get, we can cancel out that one. So we have minus r squared. It's proven. Done. Question number 1. So let me resize so that we can have more areas to answer. Question number 2. Okay, question number 2 asks you to find maximum area of the sector. Given that A is equals to 15r minus r squared, at maximum, to find maximum area, we let dA over dr equals to 0. Hence, differentiate this function in terms of r. You should get 15 minus 2r equals to 0. 15 is equals to 2r, so that r is equals to 15 divided by 2. R equals to 7.5. This is minimum r, but we want, this is maximum r, but we want to find maximum area, not maximum r. Hence, maximum area A is just, we use the maximum r, insert into the area function. 15 times maximum R is 7.5 minus with 7.5 squared. Press your calculator. You should get 56.25 centimeters squared. So that is your maximum area. I know this can be quite tough, but yes, this question will be asked in your SPM and also your IGCSE examination. So you can't run from it, you have to face it. As for homework, I would like you to do question from self-assess 9.6, question number 4, and also from your topical past year, question example 16. I hope you enjoy the video. I don't think so you will. But if you have any question, you may ask at me or send me an email. Let me know and we can discuss. I'll see you soon. Bye.